Hi, this is section 1.3 for geometry, unit 1, section 3, and we're going to be talking about the Pythagorean theorem. The Pythagorean theorem is used to find missing sides of a right triangle. Has to be a right triangle, there has to be a right angle. It doesn't work for just any random triangle that does not have a right angle. And a little bit of vocabulary, we call the two sides of the triangle that are forming the right angle the legs. So in this case, sides A and B are legs. And then the side across from the right angle, which is always the longest side of the triangle, is called the hypotenuse. So for any right triangle, the Pythagorean theorem says a squared plus b squared equals c squared. In other words, leg squared plus leg squared equals hypotenuse squared. So the hypotenuse is always by itself on one side of the equation when you set it up. For example, number 1, the 8 and 13 on this triangle are in the leg positions because those sides form the right angle together. So we are solving for x, which is across from the right angle. So it's the hypotenuse. So my setup would be 8 squared plus 13 squared equals x squared. The order of the 8 squared and the 13 squared doesn't matter. You could flip-flop those. But again, it's important that the legs are on one side and the hypotenuse is on the other side of the equation. So then 8 squared is 64, 13 squared is 169. That's a total of 233. And that's equal to x squared, so of course we need to take the square root to finish solving for x. And to the nearest tenth, that's approximately 15.3. If we move right below that to number 3, this time x that we're supposed to be solving for is in a leg position. 7 is the other leg, and 9 is the hypotenuse. So we have to say x squared plus 7 squared equals 9 squared. Again, I could reverse this order, but the hypotenuse is 9, so it needs to be by itself on the other side of the equation. So 7 squared is 49, 9 squared is 81. And this time, in order to keep solving for x, I need to subtract 49 from both sides. So x squared equals 32. And then when we take the square root, x is approximately 5.7. Then if we have something like number 5, where it's just a little more complicated picture, what's happening here on number 5, we've got the same marking on each side here of this triangle. So if this side is 24, this side is 24. This entire side length is 22, and then we've got this length to solve for that is marked as x. So when we have an isosceles triangle like this, where two sides are equal, and we've got this perpendicular dropping down to the base, this base is actually being cut exactly in half. And half of 22 would be 11. So this part is 11, and this part is 11. And so we have two congruent right triangles that are sitting right next to each other, making the big outer isosceles triangle. So we just need to focus on one side, because the two triangles are congruent, equal. So if I focus on maybe this side, x is in a leg position, 11 is a leg, and 24 is the hypotenuse. So x squared plus 11 squared equals 24 squared. 11 squared is 121. 24 squared is, hang on, let me grab a calculator. Don't know that one off the top of my head. 576. And similar to the last problem, I need to subtract 121, which gets me 455 before I take the square root and get 21.3. All right, then I'm going to flip the page and we're going to move to where it says applications. So these are just word problems that get us to set up a right triangle and then solve for something using Pythagorean theorem. So a roofer leaned a 16-foot ladder against a house. If the base of the ladder is 5 feet from the house, how high up the house does the ladder reach? So here's the side of my house. I have a 16-foot ladder leaning up against it. And the base of the ladder is 5 feet from the house. So my right angle would be here, and the question is how high up the house does the ladder reach? So in this case, x is a leg, 5 is a leg, 16 is the hypotenuse. X squared plus 5 squared equals 16 squared. That's x squared plus 25 equal to 256. And if I subtract 25 from both sides, x squared equals 231. And the square root of 231 is about 15.2, and we are talking about feet. So I'll add my units in. Maybe we'll do one more, and we'll skip down to number 12. Ashley jogged 3.4 miles east, then 5.7 miles south. How far is Ashley from her starting point? So let's say this is her starting point. She went 3.4 miles east, which is to the right when we're looking at a compass, and 5.7 miles south, which is downward. And the question is, how far is Ashley from her starting point? So here would be our right triangle. We have both the legs, and in this case, we're solving for the hypotenuse. So 3.4 squared plus 5.7 squared equals x squared. If we square both of these numbers and add them together, we get 44.05. And then when we take the square root, we get 6.6 miles.